All right, this is Mr. Spensei, your stats sensei, and we're going to go over our last quiz. This video will cover quick problem 1, and the second video will cover problem 2. So a consumer group compared the longevity of 2 types of razor blades, an inexpensive generic blade and a more expensive name brand blade. The consumer group was interested in testing the manufacturer's claim that the name brand blade remained sharper longer than the generic. 10 men who have shaved regularly were randomly assigned to either the generic blade or the name brand. After the blade went dull, the men shaved with the other blade. The number of shaves obtained before a blade became too dull to provide a close shave was recorded for each blade in the table below. All right, so it says determine at the 5% significance level whether or not the claim of the name brand manufacturer is accurate. Well, here's the situation. We need to determine what type of test we're running. Obviously, we're not running well, we could sit there and go, is this a 2 sample or is this a paired? What I would look at is we have 10 men. And so when I count up the measurements, I have 20 measurements. And if I read back again, I can tell that each man was tested twice. Because each man was tested twice, this tells me it was a paired, all right? Because we're controlling for the difference, and the purposes of that is we're controlling for the differences between individuals, between the individual beards, all right, and the individual shaving habits. So determine at the 5% significance level whether or not the claim of the brand manufacturer is accurate. Well, we need to start off with our definition. Let mu d equal the true population mean of the differences in blade life, generic minus name brand. Well, we're expecting the generic brand to last not as long as the name brand. So this gives me my inequality for my null hypothesis. So mu d equals 0 versus the alternative mu d is less than 0. Then we need to go through our 4 conditions. And they didn't say random selection or simple random survey. They said random assignment. So we need to make sure that we say random assignment, and that was given. And it's reasonable to assume this difference in blade life would be independent from one man to the other, which is to say that one man's beard and shaving habits should not impact that of another's. All right. Personally, we just need to stop up here would be independent from one man to the other. It is less than 10%. So when I did that, I plugged in and I go, all right, our sample size is 10 divided by 0.1 or times 10 is 100. And there are more than 100 men who shave. The sample size of 10 is less than 10% of the population. Finally, we need to go to our normality condition. In this case, they gave us data. So we went to stat edit. Excuse me. We went to stat edit. And I'm going to go up to and I've entered the generic in L1. I entered the name brand in L2, and I'm going to arrow up all the way and highlight L3, and I'm going to go, all right, second 1 minus second 2, and there I end up getting all the differences. So I need to go check my y equals, make sure there's nothing in there, check second stat plot. The only one I want on is the first one, so I'm only working with one graph. And I'm going to go, okay, select that by pressing enter, arrow to the left, drop down and make sure I select the stat plot that shows outliers, press enter, and my X list needs to be L3, so second 3, and I should be able to press zoom 9. Okay, please remember I can go to the trace feature and get all my information. And just looking at that box plot, it's like, that's about 50%, that's about 50%, and they're about equal lengths. So I saw no outliers, and it's reasonably symmetric. The distribution of means to be appear approximately normal. All right, you can either use a scale or you can label your box plot. Also remember, you can get that same number, that same information, go to stat calc, 1 variable statistics, second L3, scroll down, and here's my 5-number summary. All right, please don't forget that that's called the 5-number summary. All right, so that takes care of our conditions. At this point, we're going to flip over and we're going to actually run the test. So we need to write down our formula. x bar d minus mu d SD divided by the square root of n. And I start plugging in my values, all right? And I can actually get that from a couple different places, but there's negative 4.1. That's my x bar, or x bar d. Here's my mu d. There's my standard deviation. And this is the square root of 10. And right now I'm in the stat calc 1 var stats. That's not the only way I could have done that. So I can go ahead and run this thing, and I go stat test. That's just running like a one sample t. I need to make sure that data is highlighted. My mean is 0. My list was from L3. And this part's really easy to make a mistake. So go back and look at your alternative hypothesis. My alternative hypothesis was a less than. So I need to make sure I have a less than highlighted. And I calculate. And I end up getting the probability that t is less than negative 1.010. Extremely important you have this. If you don't have this, you're going to drop to a partial. All right. And this gives us a p-value of 0.1692. That's greater than our alpha level, or our level of significance of 0.05. So we're going to fail to project. What this looks like on a graph is we have a t distribution, and the claimed mean is that there was no difference. We ended up getting a sample mean difference of 4.1. This maps directly to a t statistic of 0 and negative 1.01, which is what we got here. And this little shaded area is 0.1692. All right. So our p-value is 0.1692. We failed to reject the null. There is not sufficient evidence at alpha equal 0.05 to suggest that the true population mean of the differences in razor blade life, generic minus name brand, is less than 0. So from this study, and make sure we always answer the question, and the question was, did the name brand last longer? Or more specifically, whether or not the claim of the manufacturer is accurate. For this study, we cannot conclude that the manufacturer claim is accurate. All right. So that takes care of part A. Then we have part B, and it says create and interpret a 95% confidence interval for the above scenario. Well, we already have mu d equals the true population mean of the differences. So we've already done that, and we've already done our conditions, so we don't need to redo those. And when I do that, once again, I write my formula, x bar d plus or minus t star SD divided by the square root of n. So let's go ahead and get our t star. So second vars, inverse t, and my area is going to be parenthesis 1 minus 0.95, close parenthesis, divided by 2. And you're like, ooh, I don't have my degrees of freedom. And you're like, yes, you do. You can go 10 minus 1. And in this case, I end up finding that my t star is 2.2621. So we can go to second vars. We can go stat calc 1 var stat. My data is in L3. And there's my x bar. There's my standard deviation. And I just plugged it into the formula. Now, the quick way to do this is just to go stat test t interval, which is down at number 8, and run the confidence level, and we end up getting the following: negative 13.28 to 5.076. All right. But the thing is, we don't get t star, so we have to go back and run the t star and show that work. So make sure you have that, otherwise you'll get dropped to the partial or no credit. So in this case, our conclusion for the confidence interval is we are 95% confident the true population mean of the difference lies of blade life, generic minus name brand, lies within the interval this. All right. So we are 95% confident that the true population mean lies between those values, which means generic on average lasts somewhere between 13.28 less times to more than 5.076 more times. Zeros contained, so we couldn't say that there was a difference. All right, so the next question is, the name brand claims that the razor blade may provide an average of 10 or more close shaves above that of the generic. Is this claim plausible? All right, well, 0 lies in the interval, so we can't say that there is a difference, but the question is their claim plausible? And the fact of the matter, anything that lies within this interval is plausible. So the plausible values, generic minus name brand, are 13.28 to 5.076, which means it is plausible the name brand lasts as much as 13.28 shaves longer than the generic, or the generic lasts as much as 5.076 longer than the name brand. So on average, so it is plausible the name brand lasts an average of 10 shaves longer than the generic, because 10 falls within the interval that was calculated. All right, pretty tricky there because we're just looking at a negative. Had we swapped the order and we went name brand minus generic, it would have been a little bit more obvious that it was plausible. But basically, we just said, hey, you know what? The name brand could last as much as 13.28 shaves on average longer, but we also said the generic could last that. So any value between there is plausible. We cannot say that there is a difference because 0 lies with an interval. I know that's a little bit confusing. You may want to talk to your teacher about that before you take your test. Good luck, guys. I'm about to make a video for the second question. Thank you.